and his core competencies around marine, offshore, and energy industry. And I think they will talk about easy engineering and maybe give another example of digital twin, because I think it's not a small concept. I think it's got a potential to really change the way we operate. So please go ahead.
Good afternoon, everybody. So you'll see that I am not Thomas, I'm Elgonda, but my colleague unfortunately fell ill, and I had the pleasure to be told on Tuesday that I need to present today. So here's a disclaimer: any mess-ups, that is because of the short notice. So I'm really glad that you did the presentation on the digital twin, Trygve, because that feeds in very nicely into what we want to present as well. Now, when we talk about digitalization, most people tend to jump immediately to the operational phase of an asset, and they think about things like artificial intelligence and prescriptive maintenance and unmanned installations as the type of applications that come to mind. Those are the things that are, in my view, more complex and more glamorous. And yes, digitalization can offer all of that. But I think we tend to forget that digitalization starts much more simply. It starts with data. And data starts not in the operational phase, but in the engineering phase already. And that is what Luc and I will be talking about. Luc will be talking about digitalization for engineering, and I will be talking about data in the context of digitalization. Now, if we look at this diagram, it gives an idea of how we at Siemens view the digitalization challenge. Most of the companies jump in at the top level, at the analytics and visualization layer. And that is not wrong. It is an opportunity for them to quickly dip their toes in the water, to test, to run proof of concepts, to learn. It's a good starting point, but it is not necessarily scalable, and it is not maintainable. We find that the life cycle of applications or apps are in general around 18 to 24 months. And that is just because technology changes so quickly that within that time frame, you have something better that you can use. The other reason why it's so fast is because the apps can't keep pace with the change of data in your actual environment. So managing that data structure is something that is really important. So when we look at digitalization, we start from the bottom up. We need to understand the base layer, the real equipment that you want to digitize. That goes through the electrical and the automation layer, then into a data model, which is what I want to focus on, and only then into the analytics and visualization. And we use our expertise as an OEM to do the vertical integration as far as digitalization is concerned. But we also work with our customers for the horizontal integration, because digitalization should not be viewed in silos. It should be viewed to optimize the entire value chain. Earlier this morning, we had a comment that companies are concerned about excluding competition when they select a digitalization partner. I agree that partnerships in this field is really important, and no single vendor or customer or EPC can bring the entire solution to the party. But it's really key that companies choose an open and a scalable ecosystem within which they can work with partners, where partners can bring the domain expertise around the assets and customers can contribute their domain expertise around their businesses. Now let's now talk more about the digital twin per se. And like we said earlier on, the digital twin doesn't start in the operations phase. It starts right at the concept and engineering phase, where we start to build out the process simulation. We feed that back into the concept design phase, both into the 2D and the conceptual 3D world, and then into the detailed design work, then you are looking at your detailed design documents like the PFDs, the PNIDs, the isometrics, the equipment data sheets, and the like. As you then start to go into the operate and maintain phase, you now add your time series data, your operational data, your maintenance data, and you supplement it with analytics for asset optimization and for production optimization. And this data backbone is probably the most important decision that you can make as a company, because this is not something that will become obsolete every 18 to 24 months. This is where the real value lies. Because if you are able to capture that data, and this is again not just from Siemens products, but from other products as well, and from other data sources, then you can establish that foundation from which the various apps can operate. And if this data backbone consists of asset data with attributes, then all of a sudden, the documents that you see over there just becomes reports of your data model, rather than standalone deliverables that are not integrated. So what does that mean? It means if you make a change on one of the assets in your data structure, that change propagates through all of the documents that are being shown here. Now, just having data is not enough. You do need applications. And some of the applications that I mention here is really just an example. You have your process twin. That is a model of how the physical process will respond dynamically over time. And the plant twin, which is a model of the actual asset structure. You have a variety of automated monitoring techniques and monitoring applications that we can provide from Siemens, from other OEMs, and some developed by the customer themselves. And then for some of the really complex pieces of equipment, you would still need your OEM services for the real predictive maintenance and asset optimization. But all of that can be matured, it can be expanded if the underlying data model is robust and is accurate. So we call the combination of your data model with your analytics and visualization layer the mind twin. And that consists of a number of core components. The first one is our data model itself, which contains the engineering, simulation, operations, maintenance data, and the tool we use for that is called COMAS, but that's incidental. And that then feeds the data into our 3D navigation world, which we use to navigate through the facility and then to access the data that resides within our data model. So from the 3D world, you can actually click on an asset, a piece of equipment, and you can from there spawn your KPIs, your trends, your graphical analysis. That is fully available interactively from the 3D world. And all of that is supplemented by the analytics that run in a cloud-based environment, which in the case of Siemens is called MSphere. Now, MSphere consists of three components. A Mind Connect, which is plug and play that allow connectivity between any piece of equipment and the analytics environment. MSphere itself, which provides you with the security and the data management capability, and that is a cloud environment. And then Mind Apps, which provides the tools to the likes of Siemens or the customer or any third party to access the data that resides in MSphere and develop analytics. Now, it's important to note that MSphere is an environment in which customers can publish data to the outside world for them to use. There's certainly a role for that. We also recognize that some of the data the clients would like to retain in-house. And our COMAS data architecture, the data model that I referred to previously, is where that would come into play. This gives you a sense of the type of applications that are available on MSphere. I don't expect you to go through all of them, but this is about 2-3 weeks old, and the list today is probably, there are probably 5 more apps. The number of apps that gets developed by our partners and also internally just grows exponentially over time. So it's a very open environment that customers can access. Now, for greenfields, it's easy to develop the Mind Twin because you start generating the data as you design your project. For brownfields, the effort is more because you need to retrospectively go back to capture the data for your asset, both the 2D and 3D data, and also just the data that resides in paper format. But once that is consolidated, then you can use it in the same way as you would use the Mind Twin that you've developed for a standard greenfields facility. And the benefits are clear: the access to the data, accurate data at your fingertips. And now all of you realize that we spend most of our time looking for data rather than doing valuable work from it. Now let me give you one quick case study. This is a case study for the Eva Arsen field. Now I hasten to add and say this case study was not done fully on the Mind Twin. This precedes the development of the Mind Twin, but the benefits, I think, and the outcomes are equally interesting. In this case, the platform is operating around 1,000 kilometers from the onshore control system. The platform is not fully unmanned right now, but there's a full duplicate control center onshore from which the operators can run the plant and also from which access can be given to various OEMs to the data that they need to support the operations. So subject matter experts can access data in a secure manner to support the personnel on the site. So we provided, in this case, the process twin, the model of the plant itself. We provided the integrated automation and electrical system as the foundation for the digitalization, and the site went live with a digital solution in play. There are significantly fewer people on the platform today than there would have been on a similar platform without the digital architecture, and because of the lower manning and the remote operation or the remote monitoring that we can do around the operation of the assets, the OPEX is also comparably to another platforms very positive. I think the biggest value here, though, is that this platform reached stable operation 1 week after startup. And in my book, that is that's as good as it gets. I'm going to hand over to Luke now, who will talk more to you about digitalization during the engineering phase. But I would like to reiterate what the colleague from Kongsberg has said, is that there is enormous value within the digital twin, within the Mind Twin, for you to harness.
Thanks, Elgonda.